Good afternoon, everyone. Today we're going to do a video on algebra using distributivity. And so this is something we covered in grade 8, and example 3 is mostly something we covered in grade 9, grade 10, but I thought it was an interesting equation to solve, and so I thought we would look at it. So for example 1, we're simply going to run through what distributivity is and then kind of see how to solve the equation itself. So whenever we have a polynomial, or in this case just a constant term in front of a bracket, it's implied that we're multiplying through. Okay, so 2 is multiplying the entire bracket of 3x minus 4, and so what we're going to do is multiply each term inside of the bracket individually one at a time. Okay, so if we go ahead and do that, we're going to have 2 times 3x. 2 groups of 3x is simply 6x, and then we're going to subtract 2 times 4, namely 8, and we have equals 22. And so after having ran through the bracket using distributivity, right, we distribute the 2 across the bracket, every term one at a time, right? Multiply every term one at a time. And so now we get a good old-fashioned type 2 equation, which we know how to solve. We can add 8 on both sides to get the term with the variable by itself. And so now 6x is equal to 30. And we know we have to divide by 6 for a solution of x equals 5, okay? So nothing too terribly complicated in this one. Example 2, one more term to deal with. So we're going to run through distributivity just like we did up top. The 3 is attached to the bracket, and so it's implied that we're multiplying the entire bracket, and we're going to multiply each term inside the bracket one at a time. So we have 3 times x, which is 3x, minus 3 times 8, 24. And now the minus 5, you can see, is outside of the bracket, which means the 3 is not going to multiply it at all. It's not going to be affected by the 3 that's in front attached to the bracket. The minus 5 is outside completely on its own. And so we'll have the minus 5 at the very end like this. And we still have equals to negative 11. Now we can go ahead and put these 2 terms together because these are 2 numbers, right? We know how to subtract numbers, right? So we have 3x minus 24 minus another 5 means minus 29, and we have equals negative 11. And now we're back to a nice step 2 equation. We want to isolate the term of the variable, and so we'll add 29 on both sides, adding 29, and so 3x is equal to negative 11 plus 29. So negative 11, like you lost $11, and then you win $29. So now we're in the positive with $18, okay? And now we know how to finish this off. If 3x are equal to 18, we'll divide both sides by 3 evenly, and we get a solution of x being equal to 8, okay? So 2 examples down. Now the last one, we get a nice quotient of 16 plus x in the numerator and 40 plus x in the denominator. Now, you're probably not used to having a polynomial in x, or a polynomial with an expression that involves a variable inside our denominator. But the same rules apply, okay? Whether we simply have a constant term in our denominator, or if we have an expression with a variable inside the denominator, we can deal with it in a similar fashion. So we have an x here in the denominator, which is not going to be helpful if we want to end up with a solution of x equals something, right? So our first step is to get our x back up top, no longer in the denominator. And so to get rid of this denominator of 40 plus x, we can simply multiply this entire side by 40 plus x. We'll multiply the entire thing, and so now we'll have 16 plus x divided by 40 plus x times 40 plus x. And that will make the 40 plus x completely go away, okay? And we would have to state, you'll see in high school, we'd have to state that x can't be equal to negative 40, because if x did take on the value of negative 40, we'd have 40 plus negative 40, which would be 0 in the denominator, and dividing by 0 is a big no-no in math. But for now, we'll kind of leave that be, and we'll move on ahead, just kind of dismissing that fact for now, okay? So we're multiplying the first side by 40 plus x to cancel out our denominator, and with algebra, we always have to do the same thing on both sides. And so we'll multiply the right side as well by 40 plus x. And the reason I tacked this problem onto our video on distributivity is because now we're going to have to distribute the 2 times this binomial inside the bracket. And so now with the 40 plus x canceled out, we have 16 plus x. The numerator is all that's left on the left side. And we have equals 2 times 40 plus x, okay? So now we're going to use distributivity. The 2 is attached to the bracket, and so we implied that it was multiplication, and so the 2 multiplies each term inside the bracket one at a time, and we get 16 plus x is equal to 2 times 40, 80, plus 2 times x is simply 2x, okay? Now, again, not in grade 8 because we have x's on both sides, we have a variable term on both sides, but not too terrible to deal with. We simply want them all on one side. It does not matter which side we pick. It's completely up to personal preference. Since we only have 1x here, we have 2x there. For simplicity's sake, I'm simply going to subtract 1x on this side. Now plus x minus x will just go away, and we always do the same thing on the other side. So now all we have is 16 on the left side, and it equals 80 plus 2x minus 1x leaves us with 1x, right? We had 2x, we took away one of the x's, and so we're left with 1x. And now we have 16 is equal to 80 plus x. We still want to get the x by itself. It's on the right side of the equation, but that's totally fine. We still want to get it isolated on one side, and so to do that, we can subtract 80, do the same thing on both sides, and we find that x now by itself is equal to 16 minus 80 for value of negative 64. And I know you're probably used to seeing x on the left side, so for the nice visual, we can write x to the negative 64, but you can certainly leave your solution as negative 64 is equal to x, because it is very much the same idea, okay? So I hope this was helpful. I hope this kind of tied in distributed into a trickier kind of problem where you saw something you might not have seen before. If you guys have any comments, questions, suggestions, requests for future videos, please do let me know, and thanks for watching.